F of -6. Galen? +6. So I got this would have been 36 minus 30. Good. F of -6 gives me +6. Excellent. Any questions about that? No questions? All right. Look over your homework. Page 256.
Hey, why don't you walk them through 7, because a couple people had some issues with that.
Okay.
Because they, on a couple, like number 1 and number 7, they had to get Y by itself first. So I think that was
Okay.
a little bit of an issue. All right, Devin. Here's this one. You gotta make sure you get your part up before you get that on Friday. All right.
This was a -7.
That was
Never
number
said.
10.
Okay.
Yeah, so 7.
Yeah, and somebody give me the equation for number 7, please. You get number. What's number 7?
X plus Y equals 0.
Just like that? Okay. All right. So here, if I have X plus Y equals 0, I want to get everything. I want to get the Y by itself. So, Josh, how would I get Y by itself here? Subtract what on both sides? Not Y. I want to leave Y alone. Good. I want to subtract X here. Okay. So, X minus X is 0, and then bring down my Y. So, Josh, what's 0 minus X? Huh? Negative X. Very good. Okay. So I have negative X. Now, if I want to graph this, they've not given me the points I want to graph. They've not given me my domain, so what do I use? Evan, what do I use?
What?
They've not given me my domain. So what do I need to use for my domain? What values do I put here?
-2, -1, 0, 1, 2.
-2, -1, 0, 1, and 2. Okay. So, Evan, if I'm going to plug in -2, what am I going to get for Y?
-2.
Okay, so I'd have Y equals negative X. What am I going to put in here? -2. Okay. A negative and a negative make a what? So it's going to be Y equals 2. And what about -1? What about 0?
0.
All right. At least you didn't say -0. Human calculator, Evan Dunbar. All right, if I put in a 1.
1.
Okay, here I'd get a -1 because I'm not going to have this double.
Yeah.
And then on 2, I'd get -2. Okay? What was the other one like that, Mr. Delatt?
Number 1.
Number 1. Okay.
They gave them the domain for that one, but they still had
To solve for Y?
Yep.
Christian, what was number 1? What was the function?
Like the
original problems.
Yeah, just
3x minus y equals 1.
okay. I could see where you guys would have an issue with that. All right, same thing. I want to get Y by itself. Rachel, what would I need to do first? All right, I'm going to subtract 3x. That gives me 0. I need to bring down the negative Y. Okay, that minus sign, okay, did not go anywhere. All we got rid of was this first term here. This is going to be 1 minus 3x. So I'm just going to rewrite that. I'm going to put -3x plus 1. Like Mr. Delapp said yesterday, we want to get in the habit of putting that the term with the variable in front. If I had 1 minus 3x, technically the same thing. All right, but life gets a little bit easier when we develop this habit. Okay, so Rachel, I'm not done yet because I still have that negative over there. So what do I need to do? Do what?
I don't know.
Okay, that's all right. That's why we're here. Okay. Colin, what do I need to do?
Multiply by -1.
I can multiply by -1, or I could divide everything by -1. I like to show the division step because this is kind of like multiplication here. So again, if I multiply or divide by that -1, everything just changes its sign. All right. So I'm going to end up with y equals 3x minus 1. Okay. The -3x becomes a positive 3x. This +1 becomes -1. All right. And then I'm going to use that as my function and put in the different domains that they gave you. You want me to go through that, Mr. Dila?
No, because
Okay.
I think it was what, -3, -104. Once they got there, they were okay.
Okay.
I think for the most part, to get those, it's just getting that, like you said, getting that y by itself.
Yeah. I can see us struggling with the negative y. But that's been an issue for a while when we have a minus sign and we don't do anything with it. And you guys get to that next step and you drop the negative sign or the minus sign for some reason. Okay, pay attention to those details. All right.
Hey, we need to finish one real quick thing from yesterday. Pull out your guided notes from yesterday. And then what I gave you was, for today. So just pull those out in your notebook, because there's one very back, there's a thing in the very back we need to do that I'd like to at least talk about real quick. Okay, so on the very last page. Well, shielded up today.
I did.
Was that yesterday?
Saturday.
This is also the same thing this morning.
Must look like a slob yesterday. Sounds like a Monday.
This is my fourth.
Alright. In this situation, like we told you, if they don't give you the domain, we told you to pick -2, -1, 0, 1, and 2, plug those in. Well, there are some different situations where that doesn't always make sense. So in real world situations, you might have to limit the domain to make answers make sense. Okay, so if you're talking about the number of times you go to the movie, you wouldn't go -2 times, you wouldn't go -3 times, you would go 0, 1, or 2. Okay, so the numbers you plug in will be different. Sometimes we only use non-negative values. So if you take a look at that case here, all right, you see where it's talking about that situation. A mouse can run 3.5 meters per second. So we're going to use this function. It says y equals 3.5x to describe the distance in meters the mouse can run in x seconds. Graph that function. So you see you got that big grid down there. All right, now to the left of it, go ahead and make just on your paper, because I know you don't have this whole grid, so just make an XY chart. Okay, do that to the left of that if you would. Just XY straight down there. Some people call it a T chart. All right, now what numbers can we plug in? Does it make sense to plug in -1 or -2 to see how far you can run? No, you're not going to run -2 seconds. It's okay to start at 0, just to kind of give you a starting point. Now, what is the equation? We said the equation, well, I'm going to do it over here, then I'll transfer it. The equation is y equals 3.5 times whatever x is. I'm going to make that 0. So that gives me a 0. So it's going to start out at 0, 0. Okay? So plug in 0, you get back 0 for y equals 3.5x. All right, plug in 1, plug in 2, plug in 3. Okay? And then that's going to be enough for this case. So when I plug in 1, I get 3.5 times 1, which is 3.5. I get 0, 3.5. Or not 0, 1. So I get 1, 3.5. All right, plug in 2, plug in 3, see what you get. Well, that very from yesterday's notes. not today. They were yesterday. Okay. What's it?
I was doing the ones already wrote down on here for some reason, so one's open
I will
one.
do 2, plug in 2. And then plug in, 3. Do that one. Chris, can you find out where we're at yet?
No.
We're right there at the bottom. The mouse.
Backside, right? Backside on the bottom.
Yep, very back from yesterday.
We can make that longer.
No, just do the XY chart right there. So plug in 0, 1, 2, and 3. That'll be good. And so I get Y equals 3.5 times 2. Y equals 3.5 times 3. When I plug in 2, Preston, what do I get?
7.
7. So after 2 seconds, he's run 7 meters. And after 3, what do we get when we plug in 3? 10 and a half. Good. So I got 10.5. All right, you got that big grid there. Go ahead and draw an X and Y axis, pretty similar to where I have it, because you don't have an axis on there, do you? All right, it's not marked on there.
No, they just graph.
Okay, we don't need to do it right in the middle because we're not concerned with the negative values and we're not going to get negative values. So if I'm dealing with a situation where everything's going to be positive, I can slide that over a little bit and give myself more room. Now also to make this a little bit easier to see, we only really plugged in 1, 2, and 3, right? I'm not going to make each line 1 because that's just going to crowd everything together. I want to spread it out a little bit. So this is 0 here. Let's go every 3 marks to put your scale. So I'm just going to go out to 4. So I'm going to go out to 4. And now, what's my highest Y value at this point? It's 10 and a half, right? Can I go every 2? Like make that 1? Hold on, don't do anything yet. No, I am gonna run out of room. So for the Y, go ahead and every 1 is fine. So I'm not gonna mark it 1, 2, 3, 4. That's gonna be 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. All right, what was our first point? 0 what? 0, 0. So let's put that down. 1, when I plugged in 1, what did I get? 3.5?
Yeah.
Okay, so since you got a grid there, it should be really accurate. Okay, don't just throw it down there, make sure it's accurate. 2 was 7. 2 was 7. And 3 was 10 and a half. Now, it starts at 0, 0. We never need to use the negative. So this is one case where I really theoretically wouldn't put an arrow to the left because it's not really going to go down below that for this situation. All right, what does that last sentence ask you to do on your paper? Okay, take a second, graph it, read that sentence. Grant, read that last sentence for me. What's it say?
Use the graph to estimate how many meters an hour can run in 2.5 seconds.
Use the graph to estimate how many meters it can run in 2.5 seconds. So what you do is you go to where 2.5 is. Well, that's going to be halfway in between 2 and 3. You go up, straight up, and see where it hits the line. And it hits the line right here. About what is that? It says estimate, so it doesn't have to be exactly, you can have wrong answers. You can't say 15, but you can have more than one right answer.
8.75 meters.
8.75, man, that's really accurate. Because if I go over here Now that is what you would probably get if you plugged it in. It just said estimate using the graph. So according to the graph, our little mouse would run 8.75 meters, or 8.8 or 8.7 or 8.9 in how many seconds? 2.5. So know how to read the graph to get an answer based upon what x value. So just start at that x value, go up to see where it hits, figure out where that height would be. Okay? And so that's how you would do that one. Now we didn't get to that one yesterday. I wanted to make sure we at least touched upon it, because it doesn't make any sense to plug in any negative numbers. Now this is just what Sam told me about. A mouse can run, and they put down the same thing, 8.75 meters in 2.5 seconds. So you're just using that. All right, this will be our last little section of the chapter. Okay, scatter plots and trend lines. And you should have seen these before, but like with being out that last 9 weeks last year, I don't know how hard you hit it or kind of what you remember about it. But we're going to talk about this here. All right, make sure you fill in what's missing. So a scatter plot. Okay, I think that should go where that line is. All right, we're on today's notes, the ones I just handed out a little bit ago. Hey, make sure you're keeping a nice 3-ring binder so you can keep these notes in them and you can access them like from one day to the other. We want to find a relationship between two sets of data. Okay, a scatter plot is an effective way to show some types of data. All right, so you're like in sports, like if a pitcher has a lot of strikeouts per game, does that mean he's going to get a lot more wins per game? We want to take a look and see if that makes sense. If a batter strikes out a lot, does that mean they get a lot of home runs? Okay, so the World Series is going on now, so they analyze a lot of the data. If somebody does all of their homework, do they usually get better grades? Or if somebody does very little homework, does it really affect their grades or not? So people do studies on that. So we want to take to see whether it applies. Sometimes it does, sometimes it doesn't. And we'll talk about a correlation. It's some type of relationship between two data sets. Okay? We're going to talk about a positive correlation and a negative correlation, and then there's a third one. The third one is no correlation. All right, so let me see what you got on your notes. All right, so that's right there in the middle, right? All right, how did we miss that piece up above there? Let me see something here. That's cookies in the jar. What's right above there? Game and score. All right, well, I got something messed up. Oh, hold on, let me go back. All right, is everybody good here? Got that on your paper? All right, now there's this R value called a correlation coefficient. Positive correlation means that the points are going up. It will never be a perfect line. Okay, rarely be a perfect line. Negative correlation means they're going down, and no correlation just means everything is just scattered to the wind. Okay, you really can't see what's going on. That means there's no relationship. All right, this value, this R value, is always going to be between -1 and 1. So and it's going to be a decimal, like 0.6, 0.82, -0.3. Okay, it's going to be between 1 and 1. We're not going to really go over how to find it at this point. You're just going to be asked, what will the correlation be close to? If R is close to +1, like 0.9, 0.8, 0.85, that means it is a positive correlation, the data is going up. If R is close to -1, it is a negative correlation, it's going down. And if R is close to 0, what do you think it is? No correlation. That's where everything just scattered all around. So this would be R is close to 0 for this one. This would be R is approximately -1. And this is R is approximately 1. It's closer, and the closer it gets to 0, the more scattered it is. Closer it gets to 1, the more it's almost a perfect line going up. Closer it gets to -1, it's closer to a line going down. I got my notes off. Let me see what's next.
Yeah, do you even have it on there?
I don't
You
know.
have cookies? This football?
No, they got football.
Yeah, they got football.
And I got cookies. Well, you can't have football and cookies.
I guess we should probably just wrap it up for the day, right?
Shoot. All right, here's what we're gonna do though. I think we can hop down below. Is this what you have there? You got beach
No.
visitors? No. Go back on the other side there. Okay, beach visitors. All right, good. Describe the correlation illustrated by the scatter plot. All right, you have the scatter plot in front of you, right? All you're gonna do is tell me strong, negative, or positive, negative, or no. Would that be a positive correlation, a negative correlation, or no correlation? Positive correlation. All right, here's what I want you to do. So this is the one there, no, on the front. We're still in the front. I got you guys all jacked up. Okay, so underneath there, put positive correlation. Positive correlation. Now, think about this. Which value of R would make most sense for this graph, according to what we just said? Would R be 0.7, R be negative 0.7, or R equals 0.1? All right, basically, look at it. Does this make sense to this point, or are you just like totally lost? I need a clue. Connor Hockenberry, you totally lost, or do you understand what I'm asking?
I know the answer, I don't know why, though.
What's the answer?
R equals 0.7.
Okay, that would make most sense in this case because it's a positive correlation, it's going up. Why does negative would mean it's going down, so we throw that one out. So why is 0.7 better than 0.1? Okay, Caitlin, is this making sense? No.
Let me show them a number line.
What's that?
A number line from -1 to 1. And plot those.
Why is this like specifically 0.7?
I'm just giving you
Yeah.
an estimate. We don't know what it is, but which one makes most sense?
Right.
That's what we're just trying to get you to figure
So
out.
we won't have to like list the numbers.
No,
Okay.
no. Or you might give me an estimate.
Okay, I'm good.
All right, so here on a number line, we're only talking about a range from -1 to +1. Okay, so I had positive 0.7s right here. Then I got negative 0.7, and then 0.1s right here. Okay, trying to figure out which one's closest to 1, and we know that we have somewhat of a positive correlation. We don't know how strong it is. We're not really concerned how strong it is, but we can see that it is positive. Are we in agreement there? Kind of going up and to the right. Okay. Well, then my three options here, positive 0.7 is obviously the closest to the whole number 1. All right. 0.1 is awfully close to 0. Well, what do we know about as we get closer to 0? There's less of a what, Preston?
It's more of a straight line.
More of a straight line?
No, when it gets closer to 0, it's more scattered.
Yeah,
It's like
it gets way more scattered.
totally random.
Yes. So would you guys say that's random? No, it looks like something's going on there. Okay. So we could obviously say it's 0.7. If it were going the other way, if just all those numbers were flipped and we were going down here, okay, we'd be closer to the -1. Does that help at all? Yeah.
Let's do another
All
one.
right.
Hit the other one. Oh, is there one below it?
Oh. No.
All right. Is there not another one?
Example 2. What do you guys got?
Snowboarding competition. All right, well, that's a positive. What's that type of correlation? Positive, negative, or 0?
Positive.
Positive. I should go back and wake up again. I am awful today. Awful. All right, that next one's positive. What would be how about an appropriate R value? Just, like there's no totally wrong answer, but there could be some. So if you looked at that snowboarding competition, is it pretty close to a line? Yeah, it's pretty close. So what would be an appropriate Sam R value? What do you think?
maybe like 50 or
It's gotta be between -1 and 1. And the closer it is to 1, like this one was R equals 0.7. Do you think the data in the 1 is closer to a line than this one?
yes.
If it's closer to the line than this number, then that number should be bigger than this number, but still less than 1. So what could be a possible value?
0? No.
No, Colin.
0.8.
Like anything, 0.8 or 0.9. It's not a perfectly straight line, so it wouldn't be 1. So for that one there, R equals 0.8 would be appropriate. Okay, for that. All right, now flip it over on the back.
Wait, what about this one?
You don't have this. All right, I am way off here. Hold on. All right, just pay attention then, because I don't think this one matches yours either.
What about the football one?
Huh?
What about the football one? On front.
Yeah, we're not worried about that. All right, so does this make any sense? Would this be positive, negative, or no correlation? The number of members in a family and the size of the family's grocery bill. The more members, you think their grocery bill is going to go up? That's a positive correlation. Okay, so like I said, just pay attention here. Positive. All right, this second one. The number of times you sharpen your pencil and the length of it. So the more you sharpen it, will it get longer or shorter?
Shorter.
So would that be positive or negative?
Negative.
Good, that's negative. Good. That's a negative correlation. All right, the size of your foot, whatever your shoe size is, and the grade you have in algebra. So the bigger shoe you wear, the bigger grade you have.
Yeah.
The smaller shoe you have, the lower grade you have.
So the bigger the size.
So should there be any correlation?
No.
No.
Yes.
No correlation. All right, really think about this one. The speed of a runner and the distance they can cover in 10 minutes. Speed of a runner, so the faster can they cover more distance?
Yeah.
Yeah. So I would say, if I'm going faster, I can cover more distance. That's positive correlation. That's positive correlation. And, this one's a iffy one. The year a car was made and the total mileage.
Positive.
Negative.
What?
What?
Unless you put it in a car.
What? All right, think about this.
Does the mileage increase though? Oh, the year a car was made.
Yeah.
It is. I read that. I've seen someone do it.
All right, so if you have a brand new car, it should have like 0 miles on it, right?
We'll have like 5.
Right.
For extra house.
But if you got a 10-year-old car, it's going to have some miles on it, say 75,000. If you have a 20-year-old car, it's going to have, say, 150,000. So they the way this is worded, it can be confusing. So the year a car was made, so as you get, the number gets higher, the mileage gets lower. Okay? So this would be a negative correlation. Okay. All right, do you have this one on yours? Nope. All right, maybe it's the next one.
No.
Nope. How do I have nothing the same? Nothing. Okay.
That's a double paper.
It's not 8 o'clock.
All right, just look at this here on the board.
I was trying to find like a slider that would show on like, as you
Oh, and then
flip it.
so that's how they would.
Yeah.
How they
Can't
would
find
make
it. That's
Hey, all right, listen up here. You guys got to overcome my mistakes today. All right, now just take a look at this one. This one isn't on your sheet. But let's take a look at this one. Choose a scatter plot that best represents the relation between the age of a car and the amount of money spent each year. All right, so as the older a car gets, should the repairs increase or decrease? So think about it. And we're not trying. Nobody's trying to trick you. Joe?
Positive.
Positive is correct. But the older a car gets, the more repairs it should have. Now, this one doesn't make any sense because you can't have a car negative 4 years old. So this one right here would make sense. All right, take a look at the middle of your page right there. It says, choose a scatter plot that best represents the relation between the number of minutes since a pie has been taken out of the oven and the temperature of the pie. You don't have to, you should have that one right in the middle.
Wait. Oh, yeah.
Yeah. Which one of those graphs makes the most sense of the temperature? So if you take it out of the oven, it's going to go down, right? What do you got there, Caitlin? Graph A makes sense, so make sure circle A on your paper. So this is the one that's actually on your paper. Okay, so graph A. Let's see if we match on that very bottom part. All right, that talks about the trend line. Let's see, what do you got there? Tickets and money collected. Let's see. Nope. All right, here's what I'm going to do is I'm just going to have you do
Great homework.
All right, I'm dropping it.
Same job.
I gotta go back and take
I'm going at the regular round.
This is like running in football. Like I'm so disappointed.
Oh, we're only doing Wait, do we have to do the front and back?
front only. Front only.
I'm gonna confuse, which one's the front?
No, it's that first sheet. Okay. All right, Brett in London, if you're getting this, you only need to do the front of the worksheet. The front says practice B at the top. The back says practice C. You only need to do the front. Plus, the front should have the holes on the left. Okay, for that one. So you're just doing that. We'll definitely need to hit this again a little bit tomorrow, but this will be the last part of the chapter, so we don't have to do too much more. Okay, tomorrow's Wednesday, then we'll start looking at the practice test. Because I think there's a few things we need to shore up from looking at some of your homework. So your homework is just worksheet 4-5B, no C.
Are we at homework every day?
Usually.
What?
Usually.
I said why?